Hello, today's lesson is on concentration. My name is Emmanuel Mutura, a master's student at the Aga Khan University, East Africa. The objectives of our lesson are that by the end of the demonstration, a student should be able to prepare solutions of different concentrations, determine concentrations of different solutions, and thereafter define the term concentration as used in chemistry. Here are some guiding questions on the demonstration that is going to be done very soon. You should be able to define what concentration is and observe and discuss why was their color fading when more water was added to the solution, and how was the factor of concentration handled during the experiment or demonstration. So let us observe the following demonstration. So here is our demonstration. We've got this apparatus that comprises of the water tap, a 1 liter beaker with its outlet there. Then we've got the concentration meter that is used to determine the concentration of the solution. We've got the evaporation bar here and the solute remover button. But also we've got a glossary of different solutes, out of which you can choose the one convenient to you for the demonstration. Let us choose, for instance, potassium dichromate. This is going to be our solute. It can be either in solution form or in solid state. So to begin with, we run water from the tap. And at that time, the focus should be on this point, where as water reaches here, the readings will appear on the concentration meter to show the concentration of water. In this case, it reads 0 moles per liter, signifying that in water there is nothing dissolved. That's why its concentration is 0. Then you can add some particles of potassium dichromate. Little by little, you can see the color changing. And the more you add the particles, the more the color intensifies. And also, at that point, focus on the concentration meter to see whether there is increase or decrease in concentration. So you can see the variation in numbers there. The concentration is increasing every time the particles are added, and at the same time the color of the solution is intensifying to becoming yellow and yellow and yellow. Then the point is reached when the more you add the solute particles, the more they remain at the bottom of the beaker, showing that the solution is unable to dissolve the new incoming solutes. And at that particular point, the concentration does not change. The concentration does not change. Then what happens when you add some water? So when you run some water, you see the particles that were settled at the bottom are decreasing now, meaning that the more the solution becomes dilute, the more the particles dissolve. And you can see they are disappearing from the bottom of the container. And when that particular point is reached, we say the solution is now unsaturated, and the concentration starts now changing. So the more the water is added, the lower the concentration. So you can see here the concentration is decreasing due to the addition of water. The concentration is decreasing. Then we can slide the evaporation button here to see the variation of the concentration. sliding, you can see the more the solution is evaporating, the more the concentration increases. So here the concentration is increasing as water is evaporating from the solution. Again, if we keep doing that, it will reach the point where the solution will again become saturated. And when it becomes saturated, the particles reappear at the bottom of the container, showing that they cannot be dissolved anymore because the solution is now saturated. However, when you remove the solution from the container, there is no change in concentration. No increase, no decrease. This shows that what is coming out is both solute and the solvent. That's why there is no change in concentration. The process can be repeated. If we remove the solute, it reads 0, 0, and you can add more water and change the solute. You select, for instance here, if we choose potassium permanganate, the process can be repeated. You can see the moment the particles reach water, the color changes, and at the same time the concentration also reads on the meter. And the more the particles are added, the more the concentration increases. And you can see the color also intensifying. That is deep purple color due to the addition of the particles. And again, when you add some water, the color starts changing. It fades a little bit, and at the same time the concentration is decreasing. You see the color changing and the concentration decreasing on the addition of water. So you can do in different ways by adding different solutes, and in that case you can have the concentration, the concept of concentration understood by the students. So I think here you can now come as students, you rearrange everything, you remove and begin on your own. You perform the experiment just as you have seen. At that point, you can go back to the questions that were guiding our demonstration and establish the meaning of the concept concentration by relating all the activities that have taken place to be able to come up with the workable definition of concentration. Let's go back to the questions so that we can define what concentration is based on our observation. So our guiding questions on the demonstration were: what is concentration? Why was there color fading when more water was added to the solution? And how was the factor of concentration handled during the experiment? So, based on what we have observed, the concentration of a solution is a measure of the amount of solute that has been dissolved in a given amount of solvent or solution. That is concentration. Then, a concentrated solution is one that has a relatively large amount of dissolved solute. As we saw on the demonstration, a point was reached where the particles were remaining undissolved. In that case, we say the solution was saturated. While the opposite is the case with dilute solution, is the one that has a relatively small amount of dissolved solute. That is what we call unsaturated. It can still accommodate more solutes, and once they enter there, they can still be dissolved because it is still unsaturated. So on this case, we can now ask ourselves, why was the color fading during the addition of water? It was simply because as water was added in the solution, more particles were redistributed themselves through dissolving, and in that case, the color was fading as water was being increased. But when the particles are added, the color was intensifying, signifying that the solution was becoming more and more concentrated. Now, the third question was, how was the factor of concentration handled? The factor of concentration was handled through addition of water or through evaporation of water. That's why, as we added some water, the solution was becoming diluted and the concentration was being lowered. While as we evaporated the solution, the concentration was increasing, just in the same way as the moment where we're adding the particles, the concentration was also increasing. So the addition of water lowers concentration, while the addition of particles, that means the solute, increases the concentration. Or when temperature increases, that leads to evaporation of the solvent, the concentration also increases. So reflecting on this, we can easily understand the concept of concentration. Thank you very much. And for more, if we have more questions, you can just drop them in the box and you receive the response.